Welcome, everyone. Thank you for taking the time to join us for this session. My name is Kayla Burkholder, and I'll be your host for the webinar today. We have a really great session planned for you. For those not familiar with Brinker, we're a software product company with a focus on enterprise cyber risk management. So today we're going to be talking about 7 strategies for effective vulnerability remediation. Today we'll be discussing the 7 practical strategies designed to reduce the remediation gap while improving effectiveness, efficiency, and consistency, including how to ensure that remediation efforts prioritize the most critical problems, improving your remediation coverage while reducing overhead, leveraging existing ITSM systems and processes, also while how to automate significant parts of the process. Towards the end, we're going to have a Q&A section, so please feel free to send us any of your questions throughout the webinar. Please use the webinar client to ask those, and we'll try to get as many answered as possible at the end. Today, your speakers are Syed Abdur and James Walta. Syed is our Director of Product Management. He's responsible for driving the overall strategy and technical direction of Brinker product lines. His previous experiences include technical software development and delivering large enterprise security applications at Sun Microsystems and Oracle. James Walta is our sales engineer. He is currently the lead sales engineer here at Brinker for the US and Europe. Prior to joining Brinker, he worked as a sales engineer at National Instruments, where he focused on solutions for software and hardware automation. I'm going to go ahead and hand it over to Syed to look over our agenda for today and get this kicked off.
Thank you so much, Kayla, and thank you everybody else for joining us for this webinar today. So the focus of this session is going to be vulnerability remediation. So obviously, one of the key goals of any vulnerability risk management process is to make sure that our remediation efforts are in line with what our goals are, that we're fixing the most critical problems that could potentially affect our organization, that we're doing this as efficiently and effectively as possible. Now, if you would like to see some additional content about more general vulnerability risk management, or in general what Brinker does, we have some other webinars that you can watch, or you can reach out to us and we can make sure that you get that information. But for this session, we really wanted to focus on remediation and talk about what are the main challenges that organizations face as you're defining and designing your vulnerability risk management program. What are the key characteristics that you should achieve or try to achieve from your remediation process? And then obviously we're going to cover 7 strategies that in our experience, when applied, can really drastically improve the results that are coming out of your remediation process. Like Kayla mentioned, there will be a Q&A at the end. We also have a brief demo towards the end where James is going to show us how some of these things actually look and feel in our platform. But feel free to send us any questions that you might have, and we will try to address as many of those as possible towards the end. So just getting into this, just a quick overview of what Brinker is and what we do. So we're based out of Austin, Texas. Our goal really is to help our customers take a more knowledge-driven approach to cyber risk management problems. And what we really mean by that is that our core technology product, our platform, is this really comprehensive data analytics and knowledge graph platform where we can essentially build all kinds of knowledge related to a specific problem. So when we talk about vulnerability risk management, we're actually going to a lot of additional sources besides your scanners to kind of build a comprehensive view of all the information that you need to be able to address this problem. And that's really the format that most of our customers are using our platform for different applications as well, focusing on maybe application risk or looking at configuration and change management risk. But overall, what they're trying to do is they're trying to do a better job of measuring and understanding the cyber risk that is associated with this specific type of security information. They use that information to do a better job of prioritizing the things that need to be remediated or actions that they have to take, making sure again again, that we're taking all valid data points into consideration when we're taking these decisions. And then a significant component of what we do is also reporting this risk to, again, all of your different stakeholders, whether it's your board, your executives, or your information security managers or practitioners. We want to make sure that the metrics and KRIs and KPIs that are relevant to them are reflected and communicated easily and properly. And then also providing real-time answers about cyber risk, which is really important if you think about scenarios where you have a situation that you need to address and respond to immediately. You want to make sure that all the information at your hand is as close to real-time as possible, and that's a big point of focus for Brinker applications as well. But we're going to look at vulnerability risk management today. Really try to focus and understand what are the main problems that organizations face when they try to do a better job of remediating the vulnerabilities that exist in their environment. And one of the things that kind of jumps out is this concept of a remediation gap. So a remediation gap is defined as the period of time that is spent between a vulnerability being discovered or reported, typically by your scanners, but it could also be through manual efforts like penetration testing and so on. But once a vulnerability has been identified as existing in your environment and reported to the right platforms, how long does it take for remediation actions to be initiated on those vulnerabilities? And what we really mean by that is the creation of tickets or tasks that address that particular vulnerability, that assign that task to a specific individual or to a team, and then provides whatever support and additional context is relevant for that task. So this could be additional supporting information, like how should you fix it, potential fixes, or it could be additional contextual information in terms of this is a really critical vulnerability, it's impacting this specific business function for us, and this is how much time you have to fix it. So when we talk about remediation or the initiation of remediation, that's really what we're talking about. So in this scenario, we're not even talking about how much time it takes you to actually fix the problem. What we're really talking about is how much time does it take for you to understand and address the fact that this is a vulnerability that needs to be remediated, and these are the parameters that need to conform around remediation. And one of the things that we've seen a lot of organizations struggle with is basically narrowing or reducing this remediation gap. So one research that was done into this matter kind of indicated that on average organizations take several hundreds of days to go between remediation, between identification and remediation initiation. And if you think about it, that's a pretty stark statistic, because those couple of hundred days is how much time attackers have where they have a free hand to actually exploit these vulnerabilities without you taking any actions to address that problem. And there are a few different factors that kind of go into this problem. The data overload aspect is obviously the first and most important thing, where organizations are just dealing with really large volumes of data, and they're not able to process and analyze that information in a quick enough manner to respond to it. So if you're getting millions of vulnerabilities, they all have priorities between 1 and 10. It's a pretty wide range of vulnerabilities that you're supposed to take actions on. So even if you prioritize the top criticality vulnerabilities, it's still a really large volume. So just the sheer amount of volume and data of these vulnerabilities is something that a lot of organizations struggle with. The changing attack landscape, again, sort of further complicates the problem, where it's not just about the information that you have. So you're not just responsible for analyzing these millions of vulnerabilities that you have right now. You're also supposed to look externally to understand how these vulnerabilities are actually being used, right? Is there an exploit or a toolkit that is using a particular vulnerability to exploit a compromise? So these things should should be taken into account when you're prioritizing things for remediation. And again, that is something a lot of organizations struggle with. We're going to get into this in a little bit more detail. And then the lack of business context and intelligent prioritization. So sort of building upon the two problems that we highlighted up front, again, further complicating the matters is that we don't necessarily have all the information in one place where we can take better decisions about, okay, this is impacting a really critical part of my organization, or there are some external factors that I need to make sure are incorporated into the prioritization process. And then the main culprit of the remediation gap is really the fact that we have a lot of manual actions that are part of the process. So if the expectation is that an individual or a team of individuals are supposed to go look at these millions of vulnerabilities, figure out which ones have to be fixed, and create tickets manually, understand or assign who should be fixing it, how much time should they be fixing it in. It's a lot of time that is being spent on manual efforts that can actually be codified and formalized. And so that's, again, a really big aspect of an effective remediation process, where as much of this information is put in a format that is automated and where analysis can be done automatically and actions can be provisioned automatically. And all of this essentially leads to the remediation gap, where you have vulnerabilities that exist in your environments for hundreds and hundreds and hundreds of days, which obviously is not a good thing. So let's quickly look at what a common process for vulnerability risk management looks like. So this is a sort of a generic process for how the vulnerability risk management solution within Brinker works. So upfront, what you're really doing is you're centralizing all the information from your scanners, from your asset repositories, your CMDB systems, any type of penetration testing programs that you might have running in place. So essentially any program or any system that is doing anything towards keeping an inventory of assets and the vulnerabilities that exist on these assets. So the first thing obviously is that we need to centralize all of this information, bring it together. We also have to normalize it to a common structure, because it could be coming from a lot of different tools or teams, and they might be using their own language and their own risk ratings and criticalities and so on. So one critical aspect of this is that we have to make sure that everything is conforming to a single standard. And then once we bring in all of this information, we essentially have to enhance it with any other relevant information that exists about these assets or vulnerabilities. So again, going to your CMDB systems, going to any type of internal business impact analysis, things that might be evaluating the criticality or importance of these assets. So a lot of times we get information from things like, is this a compliance relevant asset? Is this something that I should be monitoring for PCI information? What is the data context on this specific asset? So getting as much context about these assets as possible and building it into the risk model. Similarly, on the threat intelligence side, getting more real-time information about how these vulnerabilities are actually being used within the organization. Is something happening today that is going to cause me to change my risk ratings from yesterday? So again, things like that. And once we bring all of this information together, enhance the native asset and vulnerability data with this additional context, we are then able to prioritize the vulnerabilities that we should really be focusing on in a much better manner. And once we come up with those prioritizations, obviously the chunk of today's presentation, which is obviously the most important part of what we're doing, is the actual remediation. So the ultimate goal of this whole process is risk reduction, is making your organizations more secure. And the way that we can do that is by remediating these vulnerabilities and fixing these problems. But what is key is that we have to do this in a manner that is efficient and that is effective. So again, making sure that this is addressing all of our key problems and that we're managing the remediation process in a manner that is non-intrusive, in a manner that is pleasant and a good experience for the people that actually have to go through the remediation process. And then finally, reporting out to your different stakeholders. This could be through metrics, dashboards, reports, or through delivery of reports in their emails, whatever the case might be, whatever your stakeholders are most comfortable with in terms of the format of consuming this information. We need to make sure that we're presenting it in that format. So let's just really look quickly at some of the key characteristics that we want our remediation processes to have. And I'm going to try tie these characteristics with some of the characteristics or some of the strategies that we're going to look at later. But some of the key characteristics of an effective vulnerability program are that, one, it should be effective. And again, this sounds really simple, but what we're trying to say is that it should address the most critical problems that exist in your infrastructure. So the vulnerabilities that pose the greatest risk to your organization, either in terms of, they expose the most critical information, they put your most critical business functions at risk, or even that they're most likely to be exploited and used for other things. We want to make sure that however we define the criticality of these vulnerabilities, the remediation process is looking and making sure that the most critical vulnerabilities are being addressed. Then we need to make sure that it is efficient. So if we have to do a certain amount of work, we want to make sure that we're doing that as efficiently as possible. So if we're fixing 10 vulnerabilities, again, we want to make sure that the work that goes into fixing those 10 vulnerabilities is as less as possible. It should be accurate. What we mean by this is that, it should take into account that you can have duplicates, that you can have false positives. So as you're creating tickets for remediation, it takes those things into account. It also assigns the correct ownership, so it makes sure that the people that are actually supposed to be working on a problem are the ones that get assigned to these problems. It makes sure that you have the right SLAs that are being assigned and enforced. So if you have certain assets, let's say a lot of our customers that are in critical infrastructure that have to comply with NERC, they have a certain SLA that they have to meet for certain types of assets. So making sure that those things are being accurately assigned. And then finally, when we implement validation, we want to make sure that validation is accurate as well, that we're only closing tickets once everything is fixed, and that we're taking into account that sometimes there can be human errors in this process. It should be informed, so it should have all the relevant information about these assets and vulnerabilities that the security professionals that are working on it need in place. So this could be things like patching information, this could be things like exploit information, this could be things like the criticality of the assets, or what business functions are being reported. So just making sure that all the information that is relevant to the remediation action are in one place. It should be consistent, so the quality of the tickets that we're creating, the information that we're including in them, how much time people have to fix it, who it's being assigned to, these things are being set consistently and through predetermined strategies. And this is really important because, again, one of the big problems that lead to remediation gap is the fact that we have a lot of manual decisions that have to be taken when we're doing remediation, things like, who should I assign this to and how much time should they have to fix it. If we can actually codify that information as rules, it can really improve the consistency of your program. It should be predictable, so tickets should be created and validated at known times and intervals. So the folks that are responsible for fixing these problems, they should know when to anticipate either tickets being assigned to them or tickets that they've worked on be remediated. So again, try to be as predictable with our process as possible. It should be accountable, which means that it should establish clear lines of ownership and escalation. Again, this is really important if we want to have a consistent process with the way that we manage these tickets. It should be communicated, so it should automatically engage and inform all the relevant stakeholders that have to be a part of this process. It should be non-intrusive, so we want to make sure that the remediation actions that we're creating, they are not significantly adding on to people's regular work. We want to make sure that we are giving them as little work as possible to fix as many problems as possible, and that we're fitting into their existing processes as much as possible. And then it should be closed loop, which means that it should take a complete loop from identification all the way to the ticket being closed by doing things like, making sure that identification and prioritization is happening automatically, ticket creation and remediation are being tracked automatically, and then we're also validating these tickets in an intelligent manner so we can close that loop on a particular ticket or on a particular vulnerability. So just really quickly, these were some of the characteristics that are desirable when you're defining your remediation processes, and we're going to talk about some practical strategies that we've seen a lot of our customers employ that kind of help them achieve these qualities. So the first one really is incorporate business context. So why is this important? The reason why this is important is because the way that a lot of folks do vulnerability prioritization, it's by looking at external risk scoring. And it's not necessarily bad in all scenarios. Obviously, if we're talking about something like CVSS, which is a lot more static, which doesn't change over time, the risk scores that you're looking at are potentially somewhat obsolete. But if you're also bringing in exploit information and external information into that process, then it improves it a little bit. But what is still missing in that context is the fact that you still need to be able to answer questions like, does this particular vulnerability that I'm trying to analyze, does this expose any critical business functions? Or does this lead to any confidential information about my customers being exploited or being exposed? Or does this have very little impact on my business? And this is really what we mean by business context, which is an understanding of what a vulnerability or an asset actually means to your organization. And the way that you can kind of start building this is by looking at any existing systems that have information about assets like your CMDB systems. You're probably doing some type of business impact analysis where you're analyzing the criticality of your different assets. You're probably doing some type of data management or information security processes where you're keeping track of where critical data lives in your organization. And these are all things that we should be able to incorporate into the prioritization process. Now, so once we're able to do this, we're able to take much better decisions about what we should be focusing on from a remediation aspect. And the way that this helps us is that it helps us be more effective, so it helps us address the problems that have the most impact to us. It helps us be accurate, so it tries to make sure that everything that we need to look at has the correct information that we're passing along to the remediation folks, things like business context, asset criticality, and so on. And then it's informed, so it takes into account what your organizational data structure looks like and what it means to this process. Now, some of the challenges with being able to do this is obviously that in most organizations, this information is not initially centralized, so it lives in a lot of different places. That's one big thing that we help a lot of our customers with. But the first step, obviously, in this process is identifying where that information lives. So that's really the most critical thing. That's really the most difficult thing, is once you identify where this risk-relevant information lives within the organization, I think you're able to bring it in fairly easily the way that we do things, but also, if you're doing any other general data analysis and aggregation functions, once you identify where this information lives, bringing it into the process is a lot easier. The second thing is leverage threat intelligence. So again, the importance of threat intelligence is that it provides you a window into how the vulnerabilities that exist on your infrastructure or your environment are actually being used in the whole wide world. So the threat intelligence providers, they're looking at information across the entire internet in different geographies, different places, different sectors, and they're analyzing that information for very specific indicators like what particular exploits are being used the most, what vulnerabilities do they utilize, are there any common factors in how they're affecting those compromises, are there any common toolkits, are there any known actors that have shown a proclivity towards a particular vulnerability as part of their attacks, things like that. And again, the way that this helps us is it helps us be more effective. So it helps us address problems that could be most imminent to our organization. So if there is, for instance, a zero-day vulnerability that was reported yesterday, your scanner might not have had the time to pick it up yet, but if we can correlate that to your asset information, we can actually start taking some actions around that. And then also, what if the vulnerability priority for something that was evaluated as low yesterday actually needs to be bumped up to high or critical, because now we're seeing this vulnerability actually being used as part of exploit somewhere else in the world. So again, really important. It helps us be effective, it helps us be accurate, and it helps us be informed, because again, it's providing a lot more context around these vulnerabilities than what we're getting from our scanners and discovery tools. The third strategy is group vulnerabilities together. So this sounds really simple and sounds like an obvious thing, but one of the big problems that a lot of our customers have faced before when we first start talking to them is the fact that they have really, really large volumes of tickets that are being created and pushed onto the folks that are supposed to be fixing it. And what that really does is, one, obviously it reduces the efficiency of their efforts, so they're spending a lot of time, managing tickets as opposed to fixing problems, and it also kind of causes them to lose interest. So if you give them 10 things to fix versus 1,000 things to fix, you can be you can rely on the fact that they're going to put a lot more effort into fixing those 10 problems. So by grouping vulnerabilities together, what we're doing is we're trying to reduce overhead, so we're trying to reduce the total net number of tickets that we're creating, while at the same time improving the coverage of vulnerabilities that are being covered by those tickets. So initially, if you were creating 1,000 tickets for 1,000 vulnerabilities, it might be the case that you can create 20 or 30 or 50 tickets to address all of those vulnerabilities, but now you would be grouping them based on some logical constraints, like does a common fix or patch apply to multiple vulnerabilities? Maybe I should group them all together. Are these all are 100 vulnerabilities on a particular asset and they need to go to a particular person? Are XYZ vulnerabilities a certain criticality and they require a certain SLA in response? So based on common characteristics of vulnerabilities and assets, we can actually try to group vulnerabilities together and significantly reduce the number of tickets that are being pushed out to the remediation teams. Sort of in the same vein is that you should make a concerted effort to develop and enforce SLAs and ownership rules. And what we really mean by that is kind of going back to that problem that if you're taking these decisions in runtime, if you're taking decisions about who I should assign this ticket to and how much time should they have to fix it, one, it's not very consistent in the output of the ticket. So you're creating tickets which have inconsistent ownership, inconsistent SLAs, and then also the productivity of your program as a whole is not consistent. So we want to make sure that, as an organization, all critical vulnerabilities that exist on these types of systems should have a certain amount of time for them to be remediated. We want to make sure that that is something that is set in stone. If that's a hard and set rule, we want to make sure that that is enforced on every single ticket that we might be creating. And then, once you set up these rules for SLAs, for ownership, for grouping vulnerabilities together, you can really see the quality of tickets that are coming out of your remediation process improve significantly. One thing that I think James will cover in his demo is also that, what this lets you do is that it forces you to kind of think about this ahead of time as opposed to reacting to this when these vulnerabilities are coming down the pipeline. So it forces you to think about, what kinds of vulnerabilities should I be remediating, how should I be remediating them, who should be fixing certain things, and so on. And the way that we recommend customers implement this is, again, in a progressive manner, progressing through the criticality of these rules, so making sure that you're targeting your most critical vulnerabilities up front, and then kind of going through the process and addressing the less critical vulnerabilities later. The next strategy is really about using existing ITSM tools and processes. So again, this is important because the outputs of your remediation, the results that are coming out of your remediation, the actions that have to be taken on these tickets, you want to make sure that these are as non-intrusive as possible. So if you have security teams that are already using ITSM tools and processes, you want to make every effort to integrate with those processes as opposed to giving folks a new tool to look at and work on. Similarly, if you have multiple teams that are using different tools, and this is fairly common with organizations that might be, analyzing both network and application vulnerabilities, where let's say the infrastructure teams are using something like ServiceNow, and the development teams are using something like Jira, which is a more developer-friendly tool. You want to make sure that you are fitting into their processes and pushing tickets into those specific pipelines, as opposed to creating new pipelines for them to work on. So again, trying to be as non-intrusive as possible, trying to fit into these existing processes, and then similarly along the lines of communication, if they already have escalations and ownerships that have been defined, let's make sure that the remediation processes kind of conform to that. The sixth strategy is validate intelligently. again, something that sounds like, that should be a given and we should be doing automatically, but is not done very consistently in practice. And what I mean by that is when you have teams that are, let's say, taking manual actions to fix vulnerabilities and closing tickets, what is your process for validating whether that thing was actually fixed or not? Is it manual? Is somebody supposed to go look and validate that? Are you going to check it with your scanner the next time those results come in? What happens if the scanner has not scanned that particular vulnerability? So a lot of combinations and permutations that work on the validation side, but it is really possible for you to do this automatically and intelligently. So for different kinds of vulnerabilities, for different kinds of tickets, you can define different kinds of validation rules where once all the vulnerabilities have been addressed on a particular ticket, you can automatically validate with your scanner, either by kicking off like a sub-scan and making sure that all the vulnerabilities that you expect the scanner to report are being looked at right now, and that's what you're looking at to validate the remediations. And then finally, automate. So automate as much of this process as possible. The biggest hurdle to consistency and effectiveness, efficiency are manual processes. So wherever you have human intervention that is necessary, it's a potential place where your processing can fail. So try to automate as much of this process as possible. Okay, so I think with that, we are going to switch to James for the demo. So James, you have 15 minutes for the demo plus questions.
All right, thank you for that, Syed. All right, are we able to see my screen all right? Is it coming across?
Yes.
All right, perfect. All right, so as Syed discussed, there's really a good order for working through a remediation process and how we bring in additional context for better enrichment and prioritization, and then how we actually go through automating and defining a consistent process. So we're kind of going to step through some of those items here within this demo. Now, what we're looking at right now is just the home dashboard for the Threat and Vulnerability Management tool, but it gives us a very quick glance at some of the various breakdowns and distribution of the vulnerability risk within the environment. And so if we start to take a look at where some of the business context and threat intel comes in, we'll go ahead and jump over and look at a particular asset that I have pulled up within the environment. Now, as we can see, there's a lot of information that helps describe the characteristics of this particular device. We have the operating system information. We can determine the variations between the device type and know if it's a server or a database or a workstation or part of the network devices. And then from there, we can see whether it's internal or external. We have marked various compliance criteria as well. So in this case, I actually know that this particular asset has been flagged for PCI compliance. So that directly impacts the business criticality of this particular asset and helps increase the prioritization. And then we also have various relationships throughout the asset. So in this case, we actually have a direct relationship to a business service. So we'll take a look at that in just a minute. But below that, we can see all the various vulnerabilities that have been identified on this asset. And if we look at the risk score, this is a 0 to 10 calculation. And what we're doing with this score is we're actually taking into account all of these various attributes that we just looked at. So being able to use all of that business context and take into account whether servers and databases are weighted more critically than, say, a workstation, or if PCI compliance has been marked on a particular asset, then we can increase the score of the vulnerabilities that reside within that particular asset as well. And then also looking at, again, if we jump up to the business service, these are more groups of assets within the environment, but we have different criticality criteria here as well. So for this particular group called customer service, I can see what it's used for. So the environment, in this case, it's production. So we can, look at things like maybe if it's development or test, maybe we reduce the score a little bit, but if it's production, we can increase those vulnerability scores. We're looking at business criticality. In this case, it is a somewhat critical business group. So based off of that, we can adjust the vulnerability risk scores as well. And then looking at various other criteria like the ownership structure or any of the location criteria. And all of this, again, is used down at the vulnerability level to accurately calculate the prioritization of the various vulnerabilities. So once we have a good understanding of how the business context comes in, we can also look at things like threat intel feeds to understand if there's exploits or malware. We're looking at endpoint protection to identify if there are any active threats on an actual asset, and use all of that to adjust the vulnerabilities that information relates to. And so once we have all of our prioritization context within the environment, we can move on to actually using that through a remediation process. So what we're going to look at here is a ticket creation rule. So this is where some of that criteria comes into play and helps define a very consistent remediation process when it comes to ticket creation. So in this case, I have a ticket creation rule that's targeting high vulnerabilities for the Windows operating system. So every single time this rule runs, it's going to be very consistent in scope of those particular vulnerabilities. We can see how that's actually performed by looking at the various conditions. In this case, the host operating system has to contain the term Windows, and the risk rating of the vulnerability is equal to high. So this is where we start to take into account that prioritization. So that 0 to 10 score gets put into buckets with very low, low, medium, high, critical. So in this case, I'm capturing my high vulnerabilities. And through the ticket properties, I can start to define some of the actual policies that we have in place around the various scopes of vulnerabilities. So in this case, the first thing we'll look at is the SLA. So I can have a due date for each different tier of vulnerability. If I wanted to copy this ticket rule, I can jump in here and change that to medium and set a 90-day SLA. So what this does is it defines consistency within the process of creation. So every single time the rule runs, it's always going to look at the same criteria for creating those tickets and then helps define the exact same policy for SLAs. Another piece that we can look at within the ticket properties is the assignment attribute. So this is some additional business context that comes in that tells us maybe from a CMDB who's actually responsible for remediating the various assets within the organization. So in this case, for every vulnerability that we capture, we're going to look at the host that it resides on and look at the service team that is responsible for that particular asset and assign the ticket to that appropriate user or group within the environment. The last piece of the ticket creation that helps quite a bit with efficiency is the consolidation efforts. So we have access to all of the various attributes on a vulnerability, and we can actually choose which attributes vulnerabilities have in common to group by. So in this case, I'm looking at the vulnerabilities definition title, as well as the service team that it will be assigned to. So every vulnerability that has or that shares those two properties with another vulnerability will be put onto a single ticket. So some other common use cases are looking more maybe at the resolution or remediation items. So we can see, in this case, the definition solution. So I can use that as part of my remediation process and start to group vulnerabilities by similar solutions. And so once we have our tickets defined, this is kind of the framework for that consistency and consistency within the environment and having the same process repeated. So we can create different rules and have different rules capture different types of vulnerabilities. And once we actually run tickets, if we take a look at one that I've got here, this is a ticket for Microsoft Office and Office Services vulnerability. And we can see I've captured the description of the particular vulnerability, the solution that is used to remediate the vulnerability and any patching information as well. And then below that, we have a list of the, in this case, 14 assets that are affected by this type of vulnerability. And so this is how that consolidation comes into play and it allows us to view the same remediation efforts at a single ticket level. With one thing that Syed mentioned is, once we have these tickets created within the environment, It's very useful to be able to push these out to existing ITSMs that are already in use within the organization. So what we can do is actually create an external ID which links directly to the ticket that we push out to that ITSM. So in this case, I have it synced to my ServiceNow environment. So as soon as this ticket was automatically created within the Brinker environment, we pushed it out to ServiceNow, and we can see how the various fields come across. So we're able to set who opened the ticket or who's the owner of the incident, check the current state of the incident, and then we can provide a custom description field. So in this case, we mapped some additional criteria beyond just the description, listing out all of the hosts that are affected, any of the KB or solutions that relate to that vulnerability, and we can have a bi-directional sync as well. So once the workflow is existing within the ITSM and if the users are updating the current state, if they close the ticket, then we can actually pull that information back directly to the Brinker ticket. Now, the next part of the remediation process is looking at some of the automation for validation. So looking at creating an environment where we can actually track the individual progress of each vulnerability. I have a ticket here where it's a .NET Framework security update. I've got 2 hosts that are affected, and I can see that both of these status are changed to fixed. Now, the way that this happens within the Brinker environment is that we actually use rescan information. So we're looking at the 2 hosts that are affected. If the last scan date is updated for that particular asset and the vulnerability that was grabbed on the ticket is no longer found, then we can automatically change the status to a fixed state and then roll that all the way up to the ticket level and track what percentage complete that ticket actually is, and then use that for, in this case, once it's 100%, actually close out the ticket entirely. So once we have a good idea on the actual ticket workflow, how it works within the ITSMs, and we have our observations from opening to close, then we can actually move on and look at some of our remediation reports and be able to gather information throughout the remediation process at a higher level. So in this case, I have a remediation report that tells me how many tickets are open. For the ones that have closed, what's the average time to close? Also calling out the oldest open ticket. And then I have a visual distribution of the tickets within the environment. So I can see, all right, within 0 to 30 days of the creation date, I've got 329 incidents. And then I also do have a few that fall between the 60 to 100 days old. And then from there, I can see, in this case, some of the top fixes for the remediation items by priority as well as vulnerability count. So looking at the underlying score behind that value and how many vulnerabilities exist on that particular incident, I can start to rate, even inside the incidents, where should we be spending the majority of our time and what's most critical to the organization. All right, so that's all I have for the demo. Kayla, I'll let you take it back over. I think up next is the Q&A session.
Yeah, perfect. Thank you. So we do have a couple of questions that have come in. If you have a question you're interested in having answered today, feel free to submit it. And if we don't get to it, we'll go ahead and get in contact with you and get the answer to that. The first one that came through was, how does the integration with ITSM tools work?
Sure, so I can take that. So we, I think James touched upon this a little bit, but we have existing integrations with most of the common ITSM providers, ServiceNow, Jira, Remedy, all the different flavors for the most part that you have out there. And what we have is we have bidirectional integrations with all of these providers, which means that the tickets get created in Brinker through the remediation rules, and then they automatically get pushed out to these external systems. And anytime an action is taken or workflow status is changed in these external systems, it gets reflected automatically on our end, so you can still use Brinker for all the reporting and metrics and so on. Also, we have a fairly comprehensive integration with these systems. So for instance, what tends to happen is a lot of ITSM systems have their own schemas that people can customize, and they can build their own reports and objects and stuff like that. And we can actually integrate at that level as well. So we can map to these custom fields and custom values very easily.
So I think we have time for one more question here. How can you evaluate duplicates or false positives when the vulnerability can be reported by two different scanners, overlapping scan coverage?
Sure, I can take that question. So looking at vulnerabilities that may be found with duplicate scanners, we actually have a lot of capabilities within the tool to identify true uniqueness of a vulnerability and use that to either deduplicate. So if we have the same vulnerability coming from two different scanners, we can look at some of the various CVSS information and what host it resides on, and actually group those together and actually have a more rich entry for that database that combines information from both scanners. And then we can also look at things like false positives. So if we know in a particular test or development environment, we have a certain vulnerability that crops up on the same port, then we can use conditions to actually search for those vulnerabilities and identify them as soon as they come in and flag them for false positive or operational requirement and be able to exclude them based off of that criteria from any remediation items.
Thanks, James. I just want to thank everyone today for joining us and taking time out of their busy schedules to sit in on our webinar. If you have any further questions or want any more information, please feel free to reach out to us.